We're going to start chapter 20, and in this chapter it's all about chemical bonding. So the first thing we need to do is make sure when we look at a formula we're able to count how many atoms there are of each element. In order to be able to count atoms, the first thing you need to know is you need to know what a subscript is. A subscript is just that little number at the bottom of a formula that tells you how many atoms of each element you have. So remember that if a formula doesn't have one, that means it's just one of that atom. So for example, if you have water, the formula is H2O. And so that means that there's two H's and one O. The next thing you need to know is what a coefficient is. And a coefficient is that large number in front that tells you how many molecules you have. And to figure out how many individual atoms you have, you're going to multiply this number by the little number. And a coefficient in science is a lot like a coefficient in math, so this should be pretty similar to you. So the objective of what we're trying to do today is to figure out how many atoms of each element there are in each molecule. So let's do some examples. So here's an example. You have P2O3, and you have some subscripts. 2 and 3 here are subscripts, but there is no coefficient. So we could say the coefficient will be 1, just like in math. Like if you have an x, just an x by itself, you would say the coefficient would be 1. So we want to figure out how many phosphorus atoms there are. Okay, so there would be 2, because there's a little 2 right here. And then you want to figure out how many oxygen atoms there are, and there's 3, because there's a 3 right here. So to figure out how many total atoms there are, you just add 2 plus 3, so that would be 5 total atoms. So those are pretty easy. Let's do a second example. In this example, you have a molecule with a parentheses in it. Okay, so parentheses in science are a little bit like math, but they're also a little bit different. So if you have a number by your parentheses, it won't be in front, it'll be behind. So here you have an NO3 inside and a little 2 outside. The same concept applies though. You're going to be multiplying. So we want to figure out how many zinc atoms there are. So you would look next to the zinc and there's no number. Okay, and zinc is outside the parentheses. So the only thing that affects zinc is the number next to it, which there is none. So that's just 1. Okay, so now nitrogen. There is no number next to the nitrogen. That means there's 1 inside the parentheses. And then there's a 2 outside the parentheses. So you take that 1 and you multiply it by the 2. So there are 2 nitrogen atoms. Oxygen atoms. There are 3 inside the parentheses. And there's a 2 outside the parentheses. So you take 3 times 2. So that is 6 total oxygen atoms. So to figure out how many total atoms there are, you just add them all up. So 1 plus 2 is 3, and 3 plus 6 is 9. So it's 9 total atoms there. Okay, so the last one is the hardest. So you know how to do this molecule, zinc nitrate, where you have a parentheses and you have a number outside that parentheses. But what if you had a number in front of it too? Okay, so if you had 4 zinc nitrate molecules, it would look like this. Okay, so this means there's 4 zinc nitrate molecules. So we need to figure this out. So what you would do is you would do exactly what we did before. You just multiply everything by 4. See, before we had zinc and we had 1 of them, because this 2 only goes for the stuff inside there. Now we have a 4 outside here for everything. So we take 4 times the little 1. So we have 4 zinc atoms. For the nitrogen, we have 1 inside here. It's imaginary, right? And we multiply that by the little 2 outside. And we multiply that by this 4 out here. So 4 times 1 times 2. So that's 8 nitrogen atoms. For the oxygen, you have a little 3 times your little 2 like before, and then we have that times 4. So 4 times 3 times 2 is 24. So to figure out the total atoms, you just add them up again. So that's 36 total atoms. So that's the hardest kind. So that's not the only way to do it. You could do it, in different order because it's multiplication, but that's how you. Now let's practice. So take a look at the formula and let's figure out how many potassium atoms there are. Did you figure out that there are 2? Now figure out how many carbon atoms there are. Did you figure out that there are 1? And how many oxygen? Did you figure out that there are 3? So these are easy, right? I think we can all do these probably without much practice. So how many total atoms? Did you figure out that there are 6? Okay, so 2 plus 1 plus 3 is 6. Okay, so those are easy. So a little more challenging here. So take a minute, see if you can figure this out. So the strontium atoms are pretty easy, right? So you look at the subscript, look at the little number. How many strontium atoms are there? There's 3. Okay, the phosphorus atoms, okay? So look at the little number next to the phosphorus atoms. Well, there's a 1. But you have this parentheses here, and there's a little 2 outside of it. So you have to do the 1 times the 2. So there's 2 phosphorus atoms. Remember, you did not do 2 times the 3 because the strontium is outside the parentheses. Okay. Oxygen atoms. There's a 4 next to the oxygen. But remember, you have to multiply by your 2. So 4 times 2 is 8. So total atoms, 8 plus 2 is 10, plus 3 is 13. Okay. So N4, O10. Another easy one. How many N's are there? Right, 4. And how many O's are there? Of course, 10. So total atoms, 10 plus 4 is 14. Okay, so let's try one where we have 8 total Cl2O molecules. Okay. So how many Cl atoms would we have? Well, I'll give you a second to think about it. So, did you look and see how many Cl's there are? There's 2. But you have to multiply that by the 8 because there's 8 of them. So that would be, what, 16? And for your O's, there's a little imaginary 1 right here. So you have to take your 1 times your 8. So then your total molecule, so 16 plus 8 would be 24. Okay, last example, and this is tricky for 3 reasons. One reason is we have a parentheses. Okay, another reason is because we have 2 of them, so there's a big 2 in front, a coefficient in front. And the third reason is we have 2 N's, okay, 2 nitrogens. So, nitrogen atoms. Well, I'll give you a second to think about it. Okay, so if you said 6, that would be close, okay? You have a 1 right here, imaginary 1, and so you would multiply by 3 because there's a 3 outside the parentheses. And then when you have this big 2 out here, you have to multiply by that too, so you would have 6. And that's not the total answer. So we have a nitrogen right here, which has an imaginary 1 by it, so we have to add that in. But we have a 2 in front, so there's 2 of those as well. So that answer is 8. Now for our H's. We have a 4 times a 3, which is 12, times a 2, which is 24. So our total atoms in this molecule are 24 plus 8, which is 32. Okay, so we're going to practice this in class. So don't feel like you have to have this all right now, But I hope that you did take the time to actually practice it with me and not just write down my answers so that you got a head start on it.